differences between the performance of males and females isn't just due to differences in bone and muscle development. Important differences relating to the circulatory and respiratory systems also exist, which affect performance levels. The ability to consume oxygen for energy production is called oxygen uptake, or VO2. As you exercise, your VO2 increases. A higher uptake of oxygen is needed. Aerobically fit people can consume more oxygen per minute than someone who isn't aerobically fit. Everybody has a VO2 maximum, that is, a maximum level of oxygen uptake. Females typically have a VO2 maximum that is around 70 to 85% of the VO2 maximum for males. VO2 maximum is measured in millilitres per kilogram of body mass per minute. It's found by dividing a person's peak oxygen consumption in millilitres per minute by their body weight in kilograms. In this way, VO2 maximum levels can be compared between individuals regardless of their gender or size. So if Robert here has a body mass of 65 kilograms and a peak oxygen consumption rate of 2.8 litres per minute, or 2,800 millilitres, what is his VO2 maximum? 2,800 divided by 65 equals 43.08 millilitres per kilogram per minute. Here's one for you to try. There are two aerobically fit students, Thomas and Sarah. At the peak of an exercise session, Thomas, who weighs 72 kilograms, consumed 10,500 litres of oxygen over a 2-minute period. Sarah, who weighs 58 kilograms, consumed 6,264 litres of oxygen over the same period of time. Calculate their VO2 maximums, and once you've done that, comment as to whether Sarah and Thomas's figures would be typical for males and females. Ever heard someone referred to as having a big heart? In terms of males and females, it's the males that generally have the bigger hearts, or bigger heart volume to be precise. Their lung volume is also generally higher than that of females, and they have a higher hemoglobin and red blood cell count, meaning they can better supply oxygen to the muscles and use it effectively. This can be a distinct advantage for males in aerobic events like long-distance running. With a bigger heart volume, males also typically have a bigger stroke volume. That is, the amount of blood pumped out of the left ventricle with each heartbeat. Stroke volume depends on the size of the left ventricle. Stroke volume also differs at rest compared with during exercise, and we'll look at that in a bit more detail later. Heart rate is a measure of number of heartbeats per minute. Females tend to have higher heart rates than males for the same level of oxygen consumption.
35.
This is because their heart volume is smaller and their hemoglobin levels are lower, so the heart must beat faster to deliver oxygen to the working muscles during exercise.
29. Stop. That was 70, so 140.
Cardiac output, represented by the letter Q in the equation, is calculated by multiplying a person's heart rate by their stroke volume. It is measured in millilitres of blood per minute. For example, Ingrid here has a stroke volume, or volume of blood per beat, of 76 millilitres. Her heart rate is 88 beats per minute. What's her cardiac output? Females tend to have a lower cardiac output compared with males. This is linked to their smaller heart volume, even though their heart rates tend to be faster than males. Can you work out Julian's cardiac output? Multiplying the heart rate by the stroke volume gives us an answer of 7,505 millilitres per minute, or 7.5 litres per minute.